In today's class, we'll see right thread concept. Right, we'll see thread concept, and if time is there, we will go with the inner classes also. Right, what is a thread? Before going to the thread, right, we should know few terminologies. Right, right. What is a process? Right, what is a task? Right, then what is a thread? Right, we should know about these process and task. Right, what are the processes? Right, suppose. Right, just this is the definition of that. Right, a process is an independent program of execution. Right, whenever what is a process? Whenever suppose you open Google Chrome, right, or WhatsApp, or any Word document, Excel document, right, anything. What will happen? Right, whenever we will open right any software, right, it will create a one process. Right, it will start one process. Right, what it will do? CPU will allocate some memory. Right, if you want to open some right Eclipse or WhatsApp or Word document, we require some memory. Right, CPU will allocate some memory for it. Right, a process is like a independent program execution. It has a own space, resources, and life cycle. Right, it will have some life cycle also. Right, whenever we open any program, it will start the right process. Right, suppose when you run the Java application, a process is created by OS. Right, suppose if you take a real-time example, right, think of a process like a kitchen in the restaurant. Right, if you take a restaurant, kitchen is one process. It has its own space, staff, tools, right, like memory, CPU, resources. Like similarly in our language, right, system language, we will talk it as a memory, CPU time, resources. Right, it is created by who will create the process? OS will create. Whenever you open any program, right, any application, OS will create one process. Process will run independently. Right, each suppose if you start a Java application, right, it will start the JVM will start the Java application. Right, process is like a right, it's a independent process. Whenever you open any application, process will start automatically. Right, it will start one process and it will CPU will allocate memory for that. It will share some resources. Right, then what is the task? Right, then what is the task in that? Right, task is like a the task refers to unit of work to be performed. That means I want to do some task. Right, suppose right if you take here, right, a task is like a order to cook a dish. Right, you are ordering to cook a dish. That means that is one task. Right, we have to give the order to cook the dish. Similarly, right, if you want to, right, simply suppose if you open this process, right, who will do the task? There should be some task. We are doing something writing. Right, I am doing some task. Task is like a unit of work to be performed. It is not a right, but it is a concept. It is not like a thread. Task is not a thread. Who will do the task? Right, task. I said, right, do that task. Right, I ordered, right, one dish to prepare it. But who will do that? That is called a thread. That is called a thread. Task means I am giving order to do that. But actually, who is doing? Right, some person will cook it. That person is called thread. That person is called a thread. Thread is the smallest unit of execution within a process. Process will contain multiple threads. A process will contain a multiple threads. Right. A process can have multiple threads sharing the same memory. Right. Here, suppose process is there. Right. Process can have multiple threads. It can do the right? Multiple things at the same time. Right? Suppose in the system, right? In the system, what we can do? Multiple things, right? We can do, right? Suppose you have opened, right? Suppose your mobile, maybe, right? Your mobile, if you take it, you can listen songs, and the same time you can also chat. You can also chat. That means multiple tasks you are doing at same time. Who is doing the task? Right, that is called a thread. Right, a thread is the smallest unit of execution within a process. A process can have multiple threads. Right, in our suppose if you, in our Java app does file download and UI update at the same time. Right, we can download the file and update the UI at same time. You might use two threads. For one is downloading, one is to update the UI. Suppose if you take this one real time one, right? If your process in the kitchen, right? We have taken previously. Kitchen is a one process. Suppose threads are cooking, working in the kitchen. Right? Threads are cooks working in the kitchen. They share tools and ingredients, but can work on different dishes. Right? In the kitchen, multiple persons with threads. Multiple person do the task. Right? What is the task? Cooking the dishes. Right? Entire kitchen is like a process. In that process, we have a task to cook it. Multiple people, that means multiple threads, do the cooking at same time. Right? That means multiple threads. That persons are called a threads. That means if we have any process, if we are doing multiple things at same time, right? Using threads. Right here, all are combined. Right? Process, thread, task, right? Depends on. Right? Thread will do the each task. Right? Thread run the within a process, right? Share the same memory space, lightweight compared to process. Right? Process is a that is a big one. In the process, we will have a multiple threads. Right? Java supports multi-threading for better performance. Right? Like maybe right. Process is a independent program. It is created by OS. Right? Whenever you open some application, right? It will OS will create OS will create a separate memory for it to work on it. Right? If you load any application, you are open Google Chrome, that means it will create one process. It has a some memory. Right? In that process, we will do the tasks and we will have a multiple tasks. Right? In the process, suppose you have opened a browser, we have to do some tasks. Right? You have to open some right websites. Right? You have to do some perform downloading or uploading. Right, we can do uploading and downloading at same time. Right, for that two threads will be created. Right, what is the task here? Uploading and downloading. Who is doing the task? Thread is doing the task. Right, we can call thread is a lightweight sub process. Right, a lightweight process, lightweight process, sub process. That is right inside a process. It is a lightweight sub process. Smallest unit of execution. Right, it allows the program to perform multiple tasks simultaneously. By using threads, we can do the multiple tasks at a time in the process. Right, that in Java, how we will achieve it. Right, how to right, achieve it. Right, there are two ways we can do it. Right, we can achieve threading concept in multiple ways in the Java. Right, two ways. Um, okay, we'll see. By using that, there is a class called thread. Suppose suppose I am creating a one class called apply. Okay. Right, employee. Suppose if I want to make it as a thread, right? I want to make it as a employee as a one thread. That means just we will do it, just extend the thread and just we are passing some name in the constructor. Here thread method, thread is a class, right? Thread is a class, right? It has one method called run method. It has a thread has, that means inside I think parent runnable class. It implements internally runnable. It has one run method. It is a functional interface. Runnable is a functional interface. It has a one run method. Right, thread class. Right, it implements it. Right, it has a one run method. If you want to do any task, if you want to do any task, we have to do it inside a run method. Right, I have to create the thread, but a thread alone, nothing. It cannot do anything. Thread alone. For we have to tell the thread do this. Some task we have to tell the thread do this task. That we will run inside a run method. But this is inside a thread class, right? We cannot do anything, right? If we want to do anything in the thread class, what is the oops concept we have to use? We have to override it, right? Overriding. We can override and we can tell to the thread do this task, right? Tell to the thread do this task. Just let me I just am printing, right? Employee name. That's it. Whatever name in the constructor we are assigning to instance variable, just whenever you call this run method, it will print it simply. Similarly, one more task that I will create as a maybe student. Okay, right, this is one more thread. I am extending thread and then just simply student. Okay, there are two threads. One is the employee, one is the student. Right now, then create a just a simple main method. Right, then how to call those threads? Right, how to call those threads? Right, we have to create the object of student. Right, we have to pass in the constructor as a name. What is the student name? Then student dot, there is a method start. We will not call the run method. If we call the run method, thread will not create. It will not create the thread because student, we have extended student as a thread class. Student become a thread. Student become a thread. He will perform the task. Run, right? Whatever we have run, this is one task in the run method. Whatever we have given instructions, this run method will do the task. Right. If we call directly run method, there is a right. It will not give anything. Just it will simply print it. That's it. It will not do anything. Right. It will not create any thread. Whenever we will call start method, right? We call the start method. See, it will call automatically run method. Thread will call automatically that run method. It will do perform the action task. Right. Now this is one thread. Right. We student dot on the thread what we can get. We can get the name of the right name of the thread. We can print the name of the thread what it is. What else we can do? There are few methods we can right set the right set the what is this set name where it is inside a class, right? A thread name. If you want to modify the thread name, we can modify it. Right, just print it. Modify. Let me print it again. Right here, student is one thread. Main is also one thread. Main method is also a one thread. That is a default thread. Main thread is right. It is what is that? get name thread 0. Right, we set something name. Right, see, these are all different threads. This will execute by right student thread, but these printing statements will execute by main method. Right, this is one more thread, but in which order it will print, we cannot show. Right, main method is one thread, student is one thread. Which one will run first? We cannot right decide. It will internally CPU will take care of it. Right, scheduling. Right, CPU, if multiple threads are running parallelly, CPU will decide which thread to run. CPU will allocate the timings. There is a scheduler timings. Right, it will decide CPU which thread to run it. Okay, that's why see, we are first it got actually start method should print run, right, but it got printed last. It printed name first, then again we have changed the thread name Bob. Right, it got changed. Right, suppose I will make it as a thread alias. Right, name of the thread is thread alias. By default, this one is provided by JVM thread 0, 1, 2, 3 like that. If you want to modify, you can modify. Right, suppose I want to suppose okay, these are all just to see the thread details. Right, if you want to create an employee thread, right now employee. Right, we have created two threads. Right, now see which one will work first. That is decided by CPU only. Right here, executing student first and then employee. A student here only two threads. Okay, it is a executing student and employee. That means these two are executing parallel. That means these two are executing parallelly these two threads. Thread we'll see two more example. This is by using the thread class. Here we have created by using a thread class. This is one way of creation of thread. We can also create thread. We can also create the thread by using runnable interface. Runnable interface. Just one more package. Okay, same thing I will copy paste there. Okay, fine. Here what we will do, the employee, right, what is the drawback here? I cannot extend multiple classes. Right, I cannot extend. If I want to extend, there is a requirement later. I want to extend one more class. I cannot extend. Right, but by using one more way, implements runnable. Implements runnable. Runnable is what? Runnable is like a functional interface. It has a run method. Right, what are the different ways we can do runnable interface implementation? We can do by providing child class and then we can create the object of runnable interface, or we can create an anonymous inner class. Right, we have learned at the time of functional interfaces. Right, we can create by using anonymous inner class or lambda expression. Right, or by using lambda expression, we can create it. Right, fine. Right, simple. What we will do here, we will take one more example. Here, just will take one for loop. Right, just will print it. Okay, 1 to 500. Okay, I want to create just employee is working. Okay, maybe employee created 1, 2, 3, 500 employees. I want to create it. Suppose I want to write a thread. I want to print the thread name. I want to print the thread. How to get it? Thread dot current thread dot get name. We will print the thread name. I will append some space here. Okay, now fine. Okay, fine. Now similarly in the student class also, right? Just we are not doing anything, just we are printing numbers. That's it. Right? A student create. Just we are creating students, number of students. Right? Number of students. Okay. Now come to the actual thread. Right? You see, it is not allowing to create like this object because student right there is no okay because there is no constructor we have to remove it. Student and then employee what is run method. So, runnable interface. But here actually the student and employee are not actual threads. These are all just what it is calling. We did not change it. Run now implements run up. These two are not actual threads. Right. These two are not suppose. Okay. In the thread class I came. Right. I created student dot run. Right. Maybe start. See, I cannot call start method. Right. If you call the start method, then only thread will start. But there is no start method. Right. This will just a thread. Right. Similarly, one more employee also I will create and then just start the employee dot run. Right. Just we'll see what will happen if we run it. Let me keep. And here what happened? Student is first executing say student, all student, employee then. Right. This is one by one sequential. It is executing. Right. No thread is created. Right. No thread is created. Because we did not call the start method. If you call the start method, then null. But the start method is not available in right this runnable interface. Right, we are implementing runnable interface. There is no start method. Then how to create it? We have to create the threads for it. Right, we have to create a thread like thread. Right, we can create a okay student thread, and then we can give the name of the thread. Right, if you want, this is optional. If you want to give to name of the thread, we can give, otherwise not. We have to create the thread object, pass the student object here, that a student object. Then it will become a student will become a thread. Similarly, employee thread. Now if you call student thread dot start and then employee thread dot start. If you call directly run method, what will happen? There is no issue, but no thread will be created. It will execute normal way. Let's see, first it is executed student, then it is executed employee. Right, first it is executed student, then it is executed employee. Right, and nothing is happened. Right, fine. Now if we want to make it thread, we have to call the start method, then only thread will start. Now if we execute it, if we see, now if we observe here, see student executing employee. Parallelly both are executing, student and employee. Right, both are executing at same time. Right, two different threads are created. Right, student thread, employee thread. We have given names of it. Right. If you don't give names, it will create a 0 and 1. Thread 0, thread 1. Right. Currently, we have given two threads executing parallelly. That's why we are right. See here, output also mixed. Right. This is how we can create right threads in a two different way. One is by extending thread class or by extending runnable interface. So that what is the advantage if we extend runnable interface? If you want one more class, we can extend it, or multiple interfaces we can implement, or class. If you want one more class, I can extend it. Right, fine. Now this is an we are creating a object right here. Runnable is an interface, right? Runnable is a functional interface. Then how to create by using right lambda expression, right? How to create runnable instead of creating multiple classes, right? Employee, student, and then right like this. How we can create a runnable interface, right? We can create right functional interface, right? Runnable is a functional interface, right? Then runnable. This is anonymous inner class, right? This is anonymous inner class. This is runnable one, maybe suppose. Right, runnable one. How to create anonymous inner class, right? We have seen by using lambda expression how to create, right? By using suppose lambda expression, right? If you want to create by using lambda expression, right? We have to remove this part because how to create run method will not take any input, right? Empty. It will not take anything, just empty. Then lambda expression, then logic. We have more than one line, so curly brackets and end of the lambda expression, end of the method. Right, so usually this is either these two ways we can create a runnable by using either anonymous inner class or lambda expression. We can create the runnable interface. Then we can create the thread, right? We can create the threads and then we can start it. Right, we can start the thread. We can start. Okay, right. Okay, just run it. Right click, run as Java application. Right, it is running in parallel. Right, how we will do? See, thread 2 running, then thread 1, thread 1, thread 2. Right, like this. Right, now suppose if you want to execute after first thread, some scenarios, how you have a 10 threads. Sometimes what will happen? One thread depends on another thread. Right, I want to print start second thread. I want to start only before the dependent thread is completed execution. Before thread completed execution. Right, some scenarios we will get like this. Then what we can do? Then we have to suppose I want to. There is a method called join. What it will do? It will right. It will throw a checked exception. Just right add throws declaration. Right, join. What it will do? Wait for the thread one to finish before starting thread two. Right, thread two. What it will do? It will wait for the thread one to complete it. Thread one to complete it. Join method. If you call, it will right. If you run it, then you will understand. Let's see. First it is executed thread one. Then thread two start. Then thread two start. Because the join method, what it will do, it will wait to complete the thread one. Then only it will start second thread. Right. But if you have two threads, if you are using, there is no use of it. Right. You can write a normal code instead of thread. But in real time, what will happen? You will create more, right? 10 threads, 20 threads, 50 threads. In those cases, what will happen? Sometimes I have to wait for one thread should wait for another thread. Then we will use the join method to wait for other thread. Right, fine. And we'll take one more scenario. How to go? Suppose if I want to add all these, right, add all this, how many times it is looping actually? How many times it is looping? Suppose just I want to add that. It may be sometime into count. Okay, initially 0. Okay, then we have to call that method, right? Suppose we'll create okay, one method. We provide static void increment count. Okay, increment count. Right, this one. Okay, we should take this count as a this count, right? We have to keep it as a instance variable. Right, actually, how to access this count? Right, this count actually we have to go by using the right. We have to create the object, then only can access that instance variable, right? That is encrypted. But where to call this method? Okay, let me call here. Right, right. Just okay. We are trying to two threads continuously running. We want to see how many times these are all running. Total total count of it. Right, join method. Right now, just we will run it. We'll see. Hmm, see what is happening. It is printing. All threads are printing. It is 1 1 1 1 1. I think before starting thread itself, right, before starting thread itself, right, it is printing this value, so it become 1 1. Hmm, okay, fine. Now how to fix this one? Just we will add some sleep time. Just okay, maybe 10 milliseconds. That just we will wait so that right okay, here also. Oh, still 1 1 only. It is waiting, but why it's not incrementing? Why anyone can tell? What is the reason why it is printing only one? Because see what we have done, we are creating the object. Every time we are creating object, what will happen whenever we will create object? Separate memory will be created. We are incrementing. That's why it is printing only one. Right? We have did wrong. Right, then what we will do? We'll do in. Okay, we'll change this to also to static. Right, we'll change it to static. Okay, now we don't require any object directly. Inside a static method, we can call this and we'll see now. Right, count is incrementing. See, if we see, but we require a total count, right? We require a total count, right? Then we have to wait for thread one to join, thread two join. just will print the final count. Okay, final count. All right, just will remove this. I will remove this also. Just I will print a final count. I think it's better to remove this also. All right, see 926. What is the expected? Right, we'll keep 499, 499. That means 498 it should come because we have given less than, right? Just we'll keep it to make it as a equal. So that what will have, what is the expected count here? 1000. Right, and we'll remove this also. Right, we don't require. Just we are printing, that's it. We are incrementing and then printing what is the total count. Right, it should print actually 1000. Right, it should run both the threads will continue in 1000 times. But here see 930. Right, here it is can see now 1000. That means there is no guarantee that it will print every time 1000. Right, if you increase it, then we will see more. Otherwise, it's coming there. Right, it is depends on the see now it is 7000. Why it is doing like this? Right, why it is giving different? Actually, it should give 10,000. But what is happening here? It is right. What is happening is it is overriding one thread with another. Right, volatile. We have seen at right. What is the thread scheduler? What it will do? It will have a some stack memory. Right, each thread will have a separate memory, stack memory. Inside a stack memory, it will create memory for each thread. Right, memory for each thread. Object will be right. This we have a counter actually. Right, counter initially 0. What will happen? Both the threads trying to suppose sometimes what will happen? Both the thread will get the same time value. It will increment. Suppose 0. It what it will take? It will take both 0. Then 1 1. It will keep 1 1 as a 1. What is happened? Instead of 2, we got 1. Right. In sometimes what will happen? Both the threads within milliseconds of time. Right. Sometimes both threads get the same value. Right. Both threads get a same value. What happened? Both incremented correctly, but updating is done only right one value. Instead of 2, it got 1. That's why we are getting some difference in the value. Suppose to avoid this problem, last time we have discussed volatile, right? That means volatile means what? Each thread will get the latest value. Each thread will get the latest value. Right, but it is also not 100% sure. Right, we will get. It's also a see if we keep volatile also, right? It is not 100%. It will work. We cannot guarantee volatile keyword also. Right, it is also a not a better approach. It is also a not a better approach. Right, volatile will we will use only one thread is updating, one thread is retrieving. Right, if all the threads are updating, it will not work. Right, if one thread is updating, one thread is retrieving, in those cases it will work. But here both are updating. Right, both are updating the value. So in this case, we have to go with the concept called synchronized. Right, synchronized. Right, synchronized keyword. Right, if we use the synchronized keyword, what will happen? Right, we have learned somewhere we have to. Okay, change to start. Oh, okay. Okay, fine. We have to give synchronize before the start. Right, synchronize. Now we will try to run it. See, now if we run 1000 times also, it will give 10,000 only. We can get always 10,000. Right? Because what is happening here? Synchronized means what? If multiple threads are trying to update it, who come first, it will serve that one, it will allow next one. That means it will update one by one thread, but it will be very fast, but we cannot see that. But it will stop that, it will lock the thread, and it will, once operation is done, it will release the lock, second thread will go. Right, we can get it like, suppose we can have a synchronized methods, synchronized methods. We can also have a concept of synchronized means synchronized blocks. Right, we can also have a synchronized blocks. That means I can, not this. Okay, I can make it as a synchronized block like right, this code like this. We can make it either this also. But a static block, right? We cannot thread dot class. Right, we cannot use this instead is static. So we can like this also synchronized. We can make it entire method as a synchronized or only particular lines of code. If you want to only make a particular lines of code as a synchronized, right? You have a 10 lines of code here, suppose 10 lines of code. I want to make only 2 lines as a synchronized, then it will be useful synchronized. If you make it as an entire method itself get synchronized. Here only these 2 lines you want synchronized, we can make it only by using synchronized red blocks. We can use either synchronized blocks or synchronized methods, so that what will happen, we will get the consistent results, right? Consistent results. So there will be no issue, right? It will allow one by one thread only, right? I think that is right about the threads concept, right? We can do, right? These are all the some of the real time examples. Web browser, right? Download images, videos in the background while user interacts with the page. Right. Whenever you open a tab, what will happen? It will create a separate thread. In one tab, you can download. One tab, you can do some actions. Parallelly, you can do multiple things. That means that is also a threading. ATM machine, right? One thread handles the display messages, another thread handles card validation, another thread we can do the transactions. Right, we can do right charting application, games application, e-commerce website. Right, these are all right will work on a thread concept only. Right, thread will have a some life cycle. Right, thread will have a some life cycle. Right, whenever I created a thread, right, whenever I create a thread object, it will be a new state. Right, new state. Then whenever we will call start method, right, whenever we will call a start method, it will become a, whenever we are calling a start, it is ready to run. It is ready to run. That means what it will do whenever we are running a threads, right? Here CPU will be there, right? CPU will be there. CPU will take all the right. CPU will decide, right? There is a scheduling, right? If you multiple threads are coming, CPU will decide which thread will to run. That means once we started the thread, it will went to CPU. That means ready to run. CPU is once a CPU allocates the right starts the thread, it will become running state. Once you start, it will went to runnable state. That means CPU, it went to CPU. Then CPU start the thread, then it will become running state. Right, running state. Then once run state, run right, this completed run method. Right, run method is completed execution. It will become terminated. It will become terminated. Right, a new state. Then once you call the start, it will be runnable state. Once the CPU right starts the thread, it will become a running state. Then running to once run method is done, logic terminated. In middle, we also have we can while running, right, while running the thread, right, while running the thread, we can make it as a sleep. That means sometimes I want to stop this thread. Right, it can also, while running the thread, we can sleep it, then it will go to non-runnable state. That means it is a block state. We can call either sleep method, then it will block it. Then again, if you want to resume it, I want to make it as a runnable again, we can call resume method or notify all. Anything we can call resume notify all. What it will do, it will come to runnable state, not running state. It will go to non-runnables to running. Again, it will go to CPU. Then CPU again, once it is started, it will become to running state. Right? These are the 5 states we will have a thread. New state, runnable, running, terminated, then non-runnable. Right. This is the about the thread life cycle. Right. Here we will have a different terminologies. Race condition. Race condition means what? So far, whatever we have done incrementing, right? Without synchronized, what is happening? Each threads are trying to right raise it and update it improperly. Right. If multiple threads are sharing the same data, trying to update it, what is happening? We are getting inconsistent data. That is called a race condition. Multiple threads are trying to update the same data. We are getting inconsistent data. That is called a race condition. Deadlock means what? If two threads are running, right? If multiple threads are running parallel, sometimes what will happen? Right. If we use right synchronized keyword, suppose if you use the synchronized, I have used here two threads are came to update it. One thread is blocked due to some issues, right? Due to some other issue, any issue, thread is blocked. That means it is not coming outside of it. It went to inside, but it is unable to come outside. Right? Maybe due to our logic or something, it is blocked there. That means what it will happen because of synchronized keyword, it will not allow other threads. Right? One is blocked inside. It will not allow this method will not allow other threads to do any action. That means blocked. Deadlock will happen. Threads waiting on each other forever. Right? One thread is blocked inside, another thread is waiting for it. There is no release for the threads, then the deadlock condition will happen. Right. Thread safety. Then use synchronized blocks or concurrent classes to make it as a thread safe. That means whenever you are multiple updating, right, same resource, multiple threads are doing updating or deleting some action. Retrieval, there is no issue. Right. Retrieval, there is no issue. But only while trying updating, right, we will get a issue. Then in that case, to avoid race condition, we will use a synchronized keywords, synchronized methods, or synchronized blocks. We can use a synchronized. Right, if you take one real-time example, just right, how order a confirmation. Right, suppose if we take this is a restaurant application. Right, we can do order the confirmation. One thread we can start it, notify the restaurant. Parallelly, once you do the in Swiggy app, you open, right, you are doing the order. What will happen parallelly? It will update the restaurant one notification thread, start the delivery tracking GPS thread, show the timer countdown, timer thread, right? Send confirmation email, background worker thread, right? It will start all at multiple threads so that we are getting very fastly, right? Otherwise, what will happen if I wait? Suppose I have done order, it should reach to restaurant. They have to confirm it. Then second one will come notification. Right. Instead of that, if you use a multiple threads, what will happen? We will get parallel all the things we know. Right. Very quickly we will know that. Threading means simply multiple threading we will use to do the faster delivery or faster retrieval, faster access to do the task fastly. Right. To complete the task very quickly. Right. That's why we will use multi-threading concept. Right. Right. That is about the threading concept. Right, that is about the thread, how to create it, what are the different states, right? In tomorrow's class, we will see generics concept, right? We'll see generics. Okay, that's it for today's class. We have anything?